Hello YouTube, this is Elise and I am going to show you / teach you what not to do to make an iPhone charger. My goal was to learn how to make a battery-powered iPhone iPod charger that could be turned on and off with an SPST switch. It ended up just being a working LED with half of the wiring I ended up not needing because I couldn't get my USB to connect to the rest of the project. It wasn't getting any input because the resistors that I used were too large. I tried to variate from the suggested values and that ended up not working, so you really do need the exact values that they lay out for you in the instructable, which I will put a link to that instructable a little bit later. My goals for this project were to learn a little bit about wiring and soldering and resistors so that if I wanted to do a different project like this later, that I would be able to do that. Some of the technology I used were various videos, one being how to connect the voltage regulator that I used to a breadboard, and the other two were how to solder. Those were very helpful videos. And some of the actual technology or actual items that I used were resistors, capacitors, which I would suggest getting a few extra capacitors because you're probably going to fry a few, wires, and you need to make sure that those wires are able to fit inside of a breadboard if you're using a non-soldering breadboard like I did. You're going to need a regulator, an SPST switch, a 9-volt battery, a breadboard, a USB port, an LED, and a soldering iron. And then the instructable that I used is right here, and if you click on that, it will take you to that site. And the next thing is what did and didn't work in my project. The things that did work, I was able to get the LED to light up, and the switch did turn the power supply on and off, but half of my wiring didn't work because the resistors were too large. Half my wiring did work. Some of the capacitors we also fried, so those ones obviously weren't going to end up working. And then my project as a whole didn't really do what I wanted it to. I only had kind of 2 days to put that together. I'll explain that later. You will need to plan for a lot of time. This is quite a time-consuming process, especially to get all of the things that you need actually where you need them to be, because the shipping times don't always go as planned. My regulator was supposed to get here within 2 days, and it ended up taking about 5 or 6. So that was kind of frustrating, so I couldn't start building as soon as I wanted. And also, what I tried to do was, to get my USB, I had to strip it out of a wall charger. But the first thing I tried was if I hooked my battery up to that as its power source. I spent about a week and a half on that, and I only had about 2 weeks left to build after I got all of my things, so I ended up having to build my entire project from the ground up in about 2 days. That was really stressful, and I had one of my friends, Lawrence, really help me out with that. Probably wouldn't have been able to do anything without his help, and if I had to adjust my plan, I would plan for more time and I would get all of my things here sooner if possible. So that's what I would do there. This is a video of it not working. As you can see, the LED turns on when we flip the switch, and it would come up with this screen. So it would turn the phone on, but then it wouldn't actually charge it. And so it would say it still needed to be plugged into a wall. So that was very frustrating. We couldn't get it past that point, and that's still kind of where it's at, but we think it's because of the resistors, and so that's the main problem there. Problem solving is huge for this project. The instructable that we got all our information from doesn't have very clear pictures, and some of the wording is a little bit off, so you probably are going to need help from either other instructables or just online to show you exactly what things to do, especially with connecting the USB. You're probably going to have to look up what each of the pins on the USB is and what they should be connected to. I'll go over that later, but the positive and negative pins are on the outside, and then there's 2 pins in the middle that we'll talk about as well. Doing things differently, I would plan for more time, as I said earlier, and the most successful moment of my project was when we did get the LED to turn on and off with the switch. Now I'm going to show you a few pictures just so you can kind of see what items I used. One was this 9-volt battery. I would recommend getting a rechargeable battery so that you can get more than one charge from it. Next thing you're going to need is wires. As I said, you're probably going to want them to be able to fit inside the breadboard, so I would make sure you knew what thickness you needed. And the next thing is resistors. This is a 22K resistor, and the instructable says you can use two 22K and two 33K, but they also say you can use two 100K and 250K resistors, which is what I ended up trying to use. We couldn't find any 33K, and we actually couldn't find any 150K, so I had to end up soldering two resistors together to make it 156K, which is the closest we could get, which is why my project didn't end up working. Next, we have 400K resistor, which we ended up just using the resistor that came with the LED because that's what that one was supposed to be for. This is the connector for the battery, so you can attach that to other things. This is the Altoids tin that we were supposed to put the finished project in and have the switch and the LED on the outside, and then also have an opening in the side for the USB port to be able to plug the USB into. This is the wall charger that I sawed apart, and this is the actual thing that I tore from the inside. This is what I tried to connect my battery source to before we figured out that that wouldn't work. We tried to attach it to the little yellow wires you can see coming off of the yellow wrapped thing, which is the battery. And those are the power cords, and this is another picture of that. This is my SPST switch, which is actually pretty small. This, again, is the Altoids can, and back here behind it you can see the regulator, which my SPST switch is a little bit smaller than that, and versus the Altoids tin, you can see that they're pretty small because the Altoids tin is a regular sized one of those. This is the regulator. You can see it's kind of blurry. Sorry about that. Later we're going to be talking about the pins for it, so I'm just going to go over that real fast. The pin to the farthest left of this picture is the pin that is going to go in the positive side. The pin in the middle goes in the negative, and then you're going to have to bend the pin the farthest to the right to stick it in the section on the other side. But you'll see a little bit of that later. This is the breadboard that I used. As you can see, it's a non-soldering breadboard. These are the 22K capacitors. We ended up frying most of these, and we figured out that they actually weren't big enough for what we needed, so we ended up stripping one from an old TV that Lawrence had lying around when we were looking for resistors. These are some of the resistors. The little blue one is the one that was used for the LED, and the other one I think is the 100K resistor that we were using. And here is two more of the 100K resistors, and these are the 56K resistors on the other side of that. Sorry about that. We ended up having to solder them together to get the values that we needed. This one right here is the LED that we used, and then right here are some more of the wires. Now these are me trying to work with the wall charger, which we ended up just stripping the USB out of. It wasn't working the way we wanted to, and so we had to go a different route. These are the little power cords that we tried to attach it to right there, but that didn't end up working, as I said, so we ended up having to start building it from the ground up, which is what this picture is. We ended up doing this part of it, probably took us about 3 hours because we had to look up how to learn schematics for breadboards and how to read those. This is the USB that we stripped off of here is the one that we connected over here, and you have to get the pins, the 4 pins on the outside of that, soldered to wires and then attaching those. But make sure none of the pins are touching each other after you solder the wires to them, which is a little bit difficult, but it is manageable. Okay, so now we're going to talk about how to connect the battery to the board. As you can see, we attached the black negative wire to the negative side of the board, which is that side right there, and then we attached the red wire to one pin of the SPST switch, which we then attached another wire to another pin and attach that to the positive side of the board. The next thing you have to do is that is a jumping cable, or the jumping wire right there. It's attached to the negative side, and it jumps down one from where it was, and attach that and put it in the breadboard right next to, one of the wires to the LED, and attach the other wire from the LED right next to that. The next you have to attach is the resistor, which you put the second wire of the LED, and the resistor has to go right next to that and then over to the positive side. The next thing I'm going to show you is the resistor, but we ended up having to put the resistor in a different spot with the one that we stripped from the TV. So as you can see, you put one pin of the resistor and attach it to a wire, which you put into the negative side of the breadboard, and then you attach the other one to the positive side of the breadboard, which is on the other pin. The next thing that you put down is the regulator, the positive, and then the negative, and then the one that jumps over, which I already told you about, and you can see how that is just put in really simply right there. The next thing is a capacitor, which is attached to the negative side and then jumps right after the output of the regulator, right behind that one. And here we're going to talk about the wiring for the USB. This yellow wire comes down here and it goes into the line that comes from the regulator and the capacitor. And this jumping cable goes from the positive side over next to the wire for the USB. You'll see later that I ended up moving the positive jumping wire to the farthest hole out, but that comes later. And then you can see that this second wire goes 3 away from the first wire. The second one leaves a space of 1 hole, and that's the third pin. And then the last pin is 3 away again from the pin before. The wire connected to the 4th pin is 3 holes away from the wire connected to the 3rd pin. Next, we're going to talk about this jumping wire here from the 4th wire, and it goes from the negative side of the board next to the blue wire that I have on there, which is for the negative 4th pin on the USB. The next thing you have to talk about is the resistors. So right here, you can see that we have the resistors, and you can see the ones that I have soldered together. Those are going to be your 150 values, which are going to go next to the first wire and connect next to the 3rd wire. And then you're going to take that same value of resistor and put it again next to the 1st wire, and then put it next to the 2nd wire, which is one of the other green ones. So it's going to go from the first yellow wire, one's going to go to the first green wire, and the other one's going to go to the 2nd green wire. And the next resistors that you have to worry about are the 100K values, which go from the blue wire to the 2 green wires. Make sure that none of these are going in the same hole. They all have to be in their separate holes, but they are going to all be next to one another. I have finished my explanation of my project, and I hope that you found this helpful if you're looking to try and build your own iPhone charger.